Okay, working through another combo resistor. This time we've got R1 is given as 4 ohm, R2 is given as 5 ohm, R3 is given as 18 ohm, and the voltage of the battery is 12 volts. Whoever came up, I got this online. They must have been, the way they drew R1 and R2, they were probably picturing positive flow. So positive flow would leave the battery, come down through R1 and R2, some of the electricity, and another amount of electricity would go across and go through the 18. Equivalent resistance, always we kind of got to zoom out and look at the big picture. For this one, we have R1 and R2 in series with each other, following each other. So R1 and R2 are going to combine by our addition rule, 4 plus 5. R1 and R2 are going to behave like a 9 ohm resistor. So basically, we can imagine this part through the middle as being 9 ohms instead of a 4 and a 5. Now I can handle the equivalent resistance. I got to use my fraction rule. We've got the 1 over 9 from that branch through the middle, plus 1 over 18 for that other branch. Common denominator between 9 and 18 is 18. Oops, 18. We had to double the 9, so 2 over 18 plus 1 over 18 gives us 3 over 18. A little equivalent fraction work, that's the same as 1 over 6. So 1 over RT is 1 over 6. That means that the equivalent resistance is 6 ohms. So as far as the battery's concerned, the battery's got a voltage of 12 volts, and as far as it's concerned, there's 6 ohms of resistance slowing that electricity down. So to figure out the current leaving the battery from the battery's perspective, V equals I times R. The battery is 12 volts, and it feels 6 ohms of resistance. So as far as the battery's concerned, little mental math, the current works out to be 12 over 6, which is 2 amps. So what that means is 2 amps, again, picturing a positive flow, I guess. Positive flow, 2 amps come around and get to this point. Some of the 2 amps go down that way, and some of the 2 amps go over that way. As it works out, to figure out the power used by R2, we're going to have to consider that current split. So the power used by R2 is a little bit trickier than it looks. It'll take us a couple steps to get there. First thing we have to do is figure out, of those 2 amps, how many of the amps go through R1 and R2. So to figure that out, so power, eventually I'm going to use power equals I times V, but I got to take the scenic route. I need to figure out the I, and I need to figure out the V. If we consider this closed loop, 12 volts put in by the battery, the 4 and the 5, they basically act like a 9. They have to take out all 12 volts. So 12 volts get put in by the battery. I'm not sure the current going through the 4 and the 5, but I know the 4 and the 5 have a resistance of 9. So the battery put in 12, the 4 and the 5 team up, and they take out 12. And I know that the 4 and the 5 have an equivalent resistance of 9. So I can do a little bit of math to get the current. Not such nice numbers this time. 12 over 9 is the same as 4 over 3. That tells me that of those 2 amps that we talked about, of the 2 amps that get to that junction, 4 over 3 or 1.3333 go down this way, and the remaining current goes that way. If we cared about R3, 2 amps take away 1 over 3, that would tell us how much current went that way. I'm curious about R2 though. R2 now, I know 4 over 3, 1.33 amps come down through R1 and keep on going through R2. But I don't know how many volts R2 takes out, so I got to go back to V equals IR. I don't know how many volts, but I just did the work to figure out that 4 over 3 amps go through R2, and the question told me that it had a resistance of 5. So not the best numbers. 4 over 3 times 5 is 20 divided by 3. That's in volts, and I was a little bit lazy. I didn't write it. This guy back here is in amps. Now I'm ready to get the power of R2. Power is always I times V. We had to do a little bit of work, but we figured out the current going through that branch is 4 over 3 amps. And of the current going through the branch going between the 5 and the 4, the 5 took out 20 over 3 volts. So not the prettiest numbers, but when we multiply it out, 4 times 20 is 80 divided by 3 times 3 is 9. You could do the math on that. If it was 81 over 9, it would be a nice clean 9 watts. So we're going to be a little bit less than 9, like 8.111 or something like that. But that, a couple steps to get there, but that's the power taken by R2.